the course is probability module in computer engineering, but what we will do, we will talk about probability. So it's kind of a little bit of mathematics course, but I don't want you to have a very vast background of mathematics. Whatever is required, I will teach you and I will let you know. But in this course, different from the other probability courses, we will also talk a lot about the real life examples, how we can use it in so many computer engineering aspects, mainly how we can use it in English processing, pattern recognition, in telecommunication, wireless communication. So you will see the example of those things. Though we are developing a mathematical model in this course. Now, there exists lots of textbooks which you are responsible to have a look at them. But there is a book which is not mentioned in here, and it's called A First Course in Probability and Microchain. I don't think that it's available in the library because it's a 2014 book, but you can always take it from me to have a look at it. When I'm giving you homework, because I may pick up the questions from some of the books. So what will happen, instead of telling you that go to this book and do that specific homework, I will type it for you. So you will have the question in front of yourself. In other words, there is no need to buy this book. If you can find the e-book and buy the e-book, it's okay, but there is no need to have the printout of the book or any of the other books. For the exam, the materials that I will provide through the module will be enough for you in order to get 100 in the exam. In other words, I am not teaching you right, and I don't ask you left in the exam. Now, how I'm evaluating you in this course is based on 4 steps. 15% homework, 30% the midterm exam, 15% the course project, and 40% the final examination. Well, I'm so sure that you know what is a midterm exam and what is a final exam. It's a written exam, and as I said, before we start, it will be an open book, open note, and open computer exam. But your computer will not be connected into the internet. The reason for that is that you don't need to print out so many of the material, you can have it on your computer available. Course project, I will talk about it on the 3rd week, which you will choose a topic regarding to what is your research topic, and how you can use the probability in that. We will find a paper and you have to basically present that paper and simulate the paper. About the homework, I know that most of you may not like the homework, but we will have about 5 homeworks to do. So each homework will be 3%. And at the end of each topic, it doesn't mean end of each lecture. At the end of each topic, I will give you some question to work. On an average, you need to spend about 90 minutes for each of the homeworks, assuming that you understood the topic, so you need to answer the questions. Now, you can write by your hand, scan it and submit it, or you can type it and submit it. So it's up to you. I don't mind if you write it on a piece of paper, scan it and submit it, because submission is through the module. Now, this is an interactive course in the sense that I love talking and I also love to listen. So I'm expecting you to always talk, interrupt, and ask questions. I think all of you agree when there is a concept of mathematics inside it, there might be some misunderstanding. So if I say something like 2 multiplied by 5 is equal to 10, and I am not receiving any response, I assume that everyone understood it, so there is no question. But if there is a question and there is something that you don't understand, it is very simple, you please ask me. Last semester we had students who were asking about how they can add matrices. Very simple, and we describe it. So I don't know what are your backgrounds, so I assume that most of the things that we talk about for the first time. Today we will review the probability, and you might have seen many of those parts, but I assume that no one has seen them, so there will be no lack of background, so we will be quite fair. Now, how will we learn this course? Again, before we start the class, I mentioned, sometimes we will use slides, like today, we will use slides. Most of the time, I will use the board. And many mathematical examples will be provided in the class, we will solve them, but most of these mathematical examples are actually real life examples. Like it's not like only giving you some data and ask you to calculate some specific probability. We will talk how to interpret it. What is the meaning of that probability? I mean, the two of you have taken a course pattern recognition from me. You remember maybe some of those probability terms that we taught, how you can use it in the pattern recognition. But still, I will talk about these real life examples. As I said, we are videotaping these lectures, and I will put also the videos in module. So if you didn't understand some part and you want to listen to me again, you can always watch those videos. Or for any reason, if you have missed a class, you can always watch those videos. But it doesn't mean that you cannot come to me. I am staying in the first floor of this building. My room is 112, and you are welcome to come at any time. So any time that I'm in my office is my office hour, so you can come and ask me questions. And of course, you can always reach me via email. Now, about easiness of the course. Well, I personally love math, but mathematical courses are not considered as easy course. I've talked with several students when I was talking about come and take this course. They said that we took one probability in undergraduate, and that's enough for all of our life. So I can understand that how they have been scared. But I can tell you, I can guarantee you that this is a relatively easy course. So at the end of the semester, you may confirm this one. But I have taught this course before. The students didn't agree at the beginning, but at the end, they agreed with that this is a relatively easy course. Because I don't want to give you lots of information, lots of formulas, just memorize them, just know them, and just remember an example and do the example in the exam. What I want is you understand, you interpret it. Because all of you have different research. So you have, and we will talk about one, let's say, marginal probability. For each of you, marginal probability has different interpretation. So it's important for you to understand how to interpret it. Because what is the formula, how to calculate it, you can just simply go to Wikipedia, to the Google, and you can find millions of examples. The problem is that most of the researchers, they cannot interpret those formulas into the research. So in this course, I'm not telling you that at the end of the course, you can interpret everything in any form that you want. But you will have the basis and that critical point of view that you can interpret now those probability things. If you be able to get to that point that I'm aiming, then you will see that your research life will be changed. Because now you can model whatever you are talking about. In other words, whatever you have written, you can interpret them in a mathematical form. So as I said, this is a relatively easy course, but this sentence that I put in the square bracket is very typical. In other words, if you never study, if you never listen, if you play the game in the class, and then in the exam actually you open the notes for the first time, then it will not be relatively easy. You can basically learn the course right in the class. In other words, after the class is finished, you can feel confident and enjoy it if you listen properly. And as I mentioned, please ask questions if you didn't understand something. Now, we will start right after this lecture. We will start the first lecture. After this slide, we will start the first lecture. But before that, do you have any question regarding to the course, the structure of the course, something that you want to know? Anything? You're happy? Okay. Now, what we will see today, we will talk about probability theory. These are the revision of the probability, some things that you have to know before we continue the course. And we will quite spend time on each of them, and we will solve examples. We will talk about the probability theory, what is a discrete random variable. We will talk about the continuous random variable. We will talk about the distribution of these random variables, and we will solve some examples. But before that, let's get back to the early days of undergraduate when you took this probability course, or even maybe, let's say, in your high school. And let's define probability. What's probability? I mean, in the daily life, I'm sure that you have used the word probability if you're speaking English a lot. Like your friends call you and tell you that will you come to the party tonight, and you are not sure, so you say probably yes or probably no. So we use the word probably. So what is a probability? Probability means we are not certain, right? I show you that is this red, and you are all sure that this is red, so you say yes. You don't say probably it's red. So when we are not certain about something, we are using the word probable. So there is a probability. Now, let's go to the research. In the research, most of the time we are not certain. In the sense, we may do thousands of experiments, lots of readings, but still we are not so sure if this is true or not. Very good example was the Newton laws, right? For 100 years, people thought that this is true, till by our knowledge of relative theory, they found out, oh, no, this is not true. We are not so certain about all these formulas. Under some conditions, they are true. Under some other conditions, they are not. So, in the reality, most of the things that we do, especially in the science, there is always a part of not being certain. So, that's why the probability stuff become very important. Now, let's again get back to the lower level. In the mathematics, how do we calculate probability of an event? How can we calculate the probability of an event? For example, I have three colors, right? Yes. And I want to pick up one of them. What is the probability that I will pick up red? 1/3. Why? How do you calculate it 1/3?
There's 1 red and 3 chances.
Yes. So probability is defined as number of available events divided by total number of the events that we have. In other words, we were writing this probability of having event A is number of elements of A divided by number of all the sample space. So this means number of all elements in sample space. In different books they use different words. Number of elements in the world, sometimes they call it. So if I had 2 reds, then the probability will be 2/3 because I will have 2 of the event red. Now, no matter how complicated the probability is, at the end of the day, this is a way to calculate the probability. I am so sure you have seen so many integrals, so many summations in order to calculate some probability. But again, you can represent all of them by NA divided by NS. So why do we need the integrals? Why do we need the summations? Why do we need those complicated formula? Why we are not always writing as simple as this is? Because many times we don't know what is NA. We don't know what is NS. In order to calculate NA and NS, we need those integrals, those summations. So the story comes that calculating of these ones are not very simple. I don't have them in my hand. Because you are doing some experiments and you don't know what are the amount of the samples that you have, or you don't know how many times they are occurring. So we have to use so many mathematical terms, mathematical models in order to calculate this NA or this NS. But even after you have calculated it, then you can always get back and write it in this form. For instance, assume that I am telling you that I have a black box and there is a desired object inside it. The probability of getting this desired object from this black box is 93% or 93.5%. This is the probability of getting my object from this box. Doesn't matter what is the box or what is the object. Now, How can I represent this probability in this form? What is the meaning of 93.5%? Notice, but if I tell you that the probability of taking something from the box is 93.5%, what does it mean?
For example, if there are overall 1,000 options, then 935 of those are good.
Exactly. It means if there are 1,000 objects, 935 of them are my desired object. So the probability of taking that is this. So as you can see, we can always interpret these values into the definition form of the probability that we have. Now, there are a few terms that we have to know. In this course, we will use both continuous and discrete terms. So we will see both of them. But depends on the application, we will limit to one of them. For instance, the examples that I will show you on the image processing or pattern recognition, you will see that they are all in the discrete form. But the examples that I will show you in the communication, wireless communication, let's say for the mobile phones, you will see they will be all continuous. That's why in this course we need both of them. But if we are talking about the probability, let's say in pattern recognition, we will stick in the discrete form. Today in the image processing course, we will see that when we are talking about the math, I will tell you that everything is discrete, and we will see why. So a few things that we have to know. One of them is called omega. Omega means the sample space that we have, this S. Omega means the whole space that we have. F is an event. F is an event which here we have represented with the A. Yes? So, and P is known as a probability. There is a term which I want to ask you and you interpret and answer to me. I have said that the probability of omega is 1. The probability of S is 1. Can you interpret this term? Probability of the sample space is 1. Can you interpret it? Can you define the example or write the question based on this example? I said that if I want to take the red, the probability, Tony said, you said that this is, no, Anders, you said that this is 1/3, right?
Yes.
Now, can you tell me that with these three, how can I write a question which the answer is P omega is equal to 1? In other words, we want to interpret it. What is the meaning of P omega is equal to 1?
Is there a value?
Yes, what is the probability of picking up a pen or a marker? Because what is omega here? Markers. So probability of taking a marker is 1, because whatever you take definitely is a marker. So this is the interpretation. In other words, you do a chemical reaction and you are adding substance A to substance B, and you know that they always do some chemical reaction. So what is the probability of having chemical reaction? 1. So no matter what are the A and B, when you put them together, they will react, assuming that the substance will really react with each other. Now, so we said P omega is 1. What can we say about PA, given that A is a subset of omega? In other words, A is some event that we define without this, like picking up red or picking up dark colors. So it is something that we define in here. What can we say about this probability? What is the range of the value?
Less or equal?
It is less or equal to 1. So what will happen if the probability is minus 0.5? What does it mean? Or we cannot have minus 0.5. What is the probability when it is negative? What does it mean? So let's define the equation like this. What does this mean? Means there is nothing to happen, right? Like in here, if I want to give an example, what is the probability of having a blue marker? What is it? 0, because we have no blue. So 0 as Tony said is impossible. Is nothing is there. You cannot do it. So what about negative? So it is less than impossible, which means it's not possible. In other words, always probability is greater or equal than 0. So probability value cannot be negative. In the exam, you do a calculation, and if you find the value of probability negative, it means something is wrong with your calculation. So if you find a value between 0 and 1, you don't know if it is true or not. But if it is negative or if it is greater than 1, definitely something is wrong. And this is true for any probability model. It doesn't matter if it is continuous, discrete, if you have millions of integrals inside it or not, but the probability value should be between 0 and 1. So this is a very important element that we have to know. Now, here we have a very simple example. Example of a coin. You know that a coin can be a head or a tail. And the example tells that we want to toss a coin twice. So what will happen? I will toss a coin, I will get a head or tail, and I will toss the coin again. So let's see how I can find out what is omega, what is the sample space. As I told you, in the reality, calculating of this sample space is not very easy. I mean, these are simple examples, but we will see further bigger examples that we cannot calculate the S very easily. But here, I have a coin, right? I have my coin, and I toss my coin. So I will have either head or tail. Can you tell me what is the probability of having head or tail? What's the probability of having head? Only head. 0.5, 1 over 2. What about tail?
1 over 2.
Same, 1 over 2. Now, one thing that you have to note, if I toss a coin, it's either head or tail. Can it be something else? Well, we assume that it will not come on the side. So it's either come on as a head or tail. So it cannot be anything else. So these are the total thing that we have. And can we have a coin which we toss it will come as a head and tail at the same time? No. In other words, they are mutually exclusive. They cannot happen at the same time. If you toss a coin and it is head, it is not possible to be tail. Or if it is tail, it cannot be possible to be head. In this type of experiments, you will see a bit later, if we add all the value of the probability, we will get 1. So 1 over 2 plus 1 over 2, it will be 1. Now, we will continue our example. We want to toss a coin twice. In other words, I use my coin, I toss it, head comes, and I do it again. So what are the outcomes if I toss a coin again? I will get a head or a tail. Right? Now, can you tell me what is the probability of head? What is the probability of tail?
1 over 2.
1 over 2. 1 over 2 to be head or 1 over 2 to be tail. Why? Because it is a coin. It doesn't matter how many times I have done it. Right now, I toss a coin, 1 over 2 head, 1 over 2 tail. Similar thing in here. Now, the question is, if I am tossing the coin twice, what is the sample space? In other words, what is the omega? Now, I know that the first one can be head, the second one can be also head, so head, head. The first one can be head, the second one can be tail. The first one can be tail, the second one can be head, the first one is tail, the second one is also tail. So this is omega, this is how we find omega. And if you need to toss it for the third time, then you can make these three to become bigger. Why? Because this one can have 2, this one can have 2, and so on. Now, so this is how we are calculating the sample space. And as I told you a bit earlier, calculation of the sample space is not always as easy as this is. Sometimes we cannot calculate it. So what we will do, we will use a subset of this sample space, and we will do the calculation based on that. The other thing that we need to know is an event. For example, what is the probability of having the second toss to be tail? So I define A to be this. Second round is tail. Can you tell me that inside here, because what in the A we have to always go back to the omega and we find what are the samples that we have. Can you tell me that what are the possibilities to have the second round to be tail? Second round tail means that the second term should be T. Look, in other words, this one or this one, these are the second one is tail, right? Is it true? So it will be either HT or TT. Now, given this example, can you tell me that what is the probability of having the second round to be tail? In other words, what is PA? What is PA? Half. 2 over 4, this is 1 over 2. Because we have 2 elements here, 2 over 4, we have 4 elements in here, it is 1 over 2. So, this is a very simple example. I'm sure that you will not expect to see this one in the exam or anywhere. But this is a very fundamental example. In the sense that if you understand it, then you understand what do we mean by probability and what we try to calculate. Sometimes it will be nice to visualize it, and then you can count the numbers. I understand that sometimes it is not very easy to visualize it. Now, there are a few important rules that I have just mentioned. One of them, the probability is always positive. We cannot have a negative probability. Already we know probability of 0 means impossible. It doesn't exist. Not it doesn't exist. We cannot do the event doesn't exist. Assuming, what is the probability of picking up a marker from my hand? 0, because we have no marker in my hand. So negative is definitely impossible. And we also said the maximum value of the probability that we can have is 1. Simply because if we are looking at the definition of the probability, NA over NS, the number of elements in A cannot be more than the number of elements that we have in S. Because what is S? What is omega? Omega means the whole elements. So if we want to pick up the events, it cannot be more than what we have. It is like this. We have 100 euro and we want to do shopping. So we cannot do a shopping more than 100 euro because we have only 100 euro. So A, the number of elements in A, cannot be more than the number of elements that we have in S. Now, another thing that we talked was about event A and event B. they can be mutually exclusive. In other words, I have a coin, I toss a coin, it is either head or tail. We don't have a coin which it comes in my hand, it is head and tail at the same time. And now, in this type of events, which are called disjoint events. What is the meaning of disjoint event is this? They cannot occur at the same time. Like head and tail in the example of coin. For this type of events, we have this very famous formula. Probability of A or B is probability of A plus probability of B. I don't know, do you remember this notation? This is called union. You can read it as or. It means that probability of A happening or B happening. I have, let's say, 2 markers in my hand. What is the probability of having red? 1/2. And if I pick up red, can it be blue? No. Probability of blue is also 1/2, and if I pick up blue, can it be red? No. So it means that these two are disjoint. I cannot have red and it will be blue also. So they are disjoint from each other. Now, probability of A union B is this. What is the probability of having red or blue? What is it? 1. Or I can interpret it in this example in this form. What is the probability that I put my hand in and I pick up a marker which is red or blue? Because it is either red or blue, it means that it's always 1. Because it doesn't matter which one I pick up, it is either red or blue. So we can read it as interpretation to be or. There is another notation which is known as intersection. This is intersection, and we call it AND. Now, what is the probability of the marker which is red and blue? 0. In other words, if an event are disjoint, if the events are disjoint, mathematically we can write it in this form. A intersected by B is empty. This means empty. Disjoint means that A and B are not intersecting with each other. In other words, there isn't any common element between them. Head and tail, the example of red and blue, they are all disjoint because we couldn't have a coin which we toss it, head and tail will come at the same time. Now, what will happen? Or let's put it in this form. Are all the events disjoint? Are all the events disjoint? Let's do this another example. Do you remember prime numbers? Do you remember prime numbers? Prime numbers? Number which you can divide it by itself and only 1.
7.
Like 7, very good. So they are called prime numbers. Assume omega is 1 digit natural numbers. Can you tell me what are they? Single digit natural numbers. What are they? 1, 2, 3, 9. Okay? Now, A is prime numbers. So, prime numbers in omega. Can you tell me what are they?
1, 2, 3, and so.
No, 1 is not included. 2, 3, 5, 7. Very good. Now, I define B to be even numbers. What are they? What are even numbers in here?
2, 4.
2, 4, 6, 8. Now, question. Are A and B disjoint? In other words, what is the intersection of A and B? Or written in this form. Is there any element which is in A and is also in B? Yes. What is it? 2. So, this means A and B are joint. Because this joint means this should be empty. We shouldn't find any element. Yeah. In other words, probability of P or B is not equal to probability of A plus probability of B. So what will happen if we have a joint probability? What will happen if we have, joint events, like in here? P, they have A, they have B, they are joint. What is the probability of event A or event B? In other words, what is the probability that I put my hand inside this bag and I will pick up a number which is even or prime number? So it's even or prime number. In that case, we are using this formula. Probability of A or B is probability A plus probability B minus the probability of the joint. So why is it like that? Let's see. We will get back to the definition. We will get back to the we will get back to the definition. This is my last page. No problem. This is the last thing that we have to do. I don't want to escape in the first class. A or B, which means it is a prime number and it is an even number together. Can you tell me what are those numbers? Between 1 to 9. Tell me the numbers which are prime numbers and which are
2, 3, 4.
2, 3, 4, 5, 6, 7, 8. So it will be 2, 3, 4, 5, 6, 7, 8. Can you tell me what was A? Prime numbers? 2, 3, 5, 7. What are B's? 2, 4, 6, 8. Now, how many elements do I have here? 1, 2, 3, 4, 5, 6, 7. How many elements are in here? How many elements are here? 4. Now, we know that if I want to look at what is the the total number of A or B together, by looking at this, I will say 1, 2, 3, 4. This is in here, so I shouldn't count it. So 5, 6, 7, right? This is how we do it. In other words, what will happen if I consider this one again? So it will be 1, 2, 3, 4, 5, 6, 7, 8. But how many of them are repeated ones? So I have to remove it. In other words, A and B together is number 2, which has one element. So it means that total number of A or B is total number of A plus total number of B, but some of them are repeated, minus those repeated ones. So, because this is the way, so what is the probability, definition of the probability? Divided by n omega, divided by n omega, divided by n omega, divided by n omega. So, this means the probability of A or B is equal to probability of A plus probability of B minus probability of A or B, A and B together. So, this is the proof of this actually, that how we have to do it. Now, this is a general formula. Why I call it general formula? Because if A or B is empty, what does it mean? It means that n of A or B is equal to n of A and B is equal to, how many elements do I have here, Murtaza? 0. So this means that probability of A and B, Pejman, is 0. So if this term is 0, so for the disjoint event we have probability of A or B is PA plus PB minus 0, we should write. So you see that this is a general formula for a disjoint event. We can get the formulation that we had before. Now, this was an example that I showed to you. We have to generalize it, because if you want to put a law, you cannot put with one example, or you cannot have 100 examples and make a law out of it. If you want to have a general rule, you should have it for any type of set. So what is happening is that in probability, we have a very strong tool, which is called band diagram. This is called a band diagram. We can use a diagram like this in order to make a general rule. It says that assume that this is the rectangle is the whole space that we have. It's the sample space. And A is my event. Because A is always inside S, in other words, the probability should be always less than equal to 1, because maximum is that A and S is the same. We don't have this word. I don't want to also, as I said, scare you. We will talk about how we can use this band diagram in order to represent these disjoint and joint probabilities. With high probability, again, it's the probability course, so with a high probability, you have seen all these ones even in the high school. I don't mind of spending some more hours to review those materials before we actually start to talk about what we want to learn in this course. I am sure that you might be familiar with the probability distribution function, cumulative values, cumulative probability distribution function, or maybe not. I assume you are not, and I will teach you all of them, because these are the things that you need to know in order before we start to talk about real stuff. The real stuff starts from the first page of this book. So before we start this book, we need to review some of these materials. These are quite simple materials. So if you find them boring, please bear with me for a few more hours so I can review all of them. So when I am talking about more advanced things, you know the terminology, you know what I'm talking about. Now, there will be 2 more students who I know that today they could not make it. So I think I will stop now, and I will see all of you tomorrow. But before I dismiss the class, do you have any question?
Will you be videotaping tomorrow's lecture?
Yes, every day.
I probably can't make it.
Okay, every day I will videotape it. The high probability what will happen is that this week, which is like tomorrow, I will all review the things that you need to know. And starting from next week, assuming that tomorrow we can finish it, we can start the topics which are like the first topic of this course. These are all revision in order to make sure that everyone has the same background. Any question, any comments? Is the course scary? Not yet. Yeah. Scary? Not scary. Okay. Okay, if you have no question, this is the end of the lectures. I will see you tomorrow. Thank you. You have to press the same button.